Hello, welcome to episode 14 of live.withcode.uk. Well done to everyone who took part in the Python activity last week. A particular well done to Amy from All Saints, who won last week's competition. It was all about encryption with a Caesar cipher last week. So I'll confirm with your teachers and your parents about permissions to be able to send out your certificate and prize as soon as I can. I'm quite excited about this week. It's all about robotics with a Raspberry Pi, so thank you to everyone who voted for that one. Today, you don't need a Raspberry Pi and you don't need any robotics. It will all work in the browser. Looks very complicated when you run it, but the idea is these are the pins from a Raspberry Pi. And if we go to a Raspberry Pi camera, this was my son's, one of my son's radio-controlled diggers. It's an amazing toy. I don't believe in affiliate links, so I'm not going to share links for you to purchase it, but you can search for it if you want. There's a Raspberry Pi. I've kind of hacked into it and plugged in the Raspberry Pi GPIO ports to be able to control it. So don't worry if you haven't got that at home. I want you to take away from today's video what is possible with Python beyond just kind of text-based stuff. So the idea is we've got 6 motors. So physically on the actual digger, they'll control how it moves. You'll see that in a bit. You can choose which motor we want to go for. So let's go for motor 0, put it to full speed, or 1. Press enter to stop. So at 0 for the first one again, you can make it go backwards or anything in between. So 0.5 makes it go a bit slower. And then 5, let's try that. So you can control the speed of all of these differently. The wiring looks a little bit messy. If you're wondering, these integrated circuits here are controllers, H-bridge controllers. You can't plug a motor directly into a Raspberry Pi because when a motor stops spinning, it sends some electricity back which can damage a Raspberry Pi. And these controllers let you adjust the speed and control the motors, make them go in both directions. So that's what we're aiming for. We will do live coding in a sec, but let's test it on the actual Raspberry Pi to see if it works. We want to connect to, I've set up the Raspberry Pi so it's on the same Wi-Fi network. So a Raspberry Pi will default to a host name of Raspberry. I'm using Putty, which is free to download to be able to connect to it remotely from my laptop. Default username is Pi, default password is just Raspberry, but mine is slightly different. And then I'll change the text size so that you can see what's going on here. Change settings, let's see, appearance, change the size, and let's go for size 18. Great, ls to list the file. So this is running on the Raspberry Pi at the moment. So on that device thing there. Let's go inside the digger folder, cd, change directory, digger, and there's nothing, oh there is something in there at the moment. Nano is a text editor you can use in the console window. Let's have a look. So yeah, the same code that we've got in here. Control X to close. Now on a Raspberry Pi you have to be careful. If you run just Python, it will do Python 2 and we use Python 3. So you have to explicitly say Python 3 and then the name of the file. So hopefully it's running. It's the same code that we had in Create with Code before, but instead of displaying the simulated stuff, which is nice for development, hopefully it's going to control the actual device. Now at the moment it's powered by the power supply into the Raspberry Pi. So I don't run down the battery. I've just switched on the battery, so it would work if I unplugged the power supply now. So let's go for motor 0 and full speed. Quickly stop it before it falls us off and crashes. Let's try backwards. And then hopefully also, let's do 0.5 so it goes a bit slower. And then hopefully you can choose any of these and see the thing actually moving. That's quite exciting. So obviously not all of you will have this set up at home, but it hopefully gives you an opportunity to see what is possible. You can do anything. You can make your own gadgets. I've got students who've designed all sorts of robotic stuff with some cheap hardware on a Raspberry Pi that could literally change the world. It's really exciting. Okay, yep, let's close that down and turn the Raspberry Pi camera off. Switch the battery off and do the live coding so that you can work out how this all works. So our focus of today's session is all about logical errors, which are the hardest ones to debug, and iteration, so some loops. So let's get started together. To begin with, we're going to import the GPIO0 module, which was made by Ben Nuttall and Dave Jones. It just makes it much simpler to control devices on a Raspberry Pi. There is also an RPi, I can't remember the capitalization, which gives you low-level control over each of the pins, but sometimes it's easier to know what you're connecting to it, as in a motor or an LED or different sensors, that kind of things. So GPIO0 is much easier to get started with. We're going to say, help, don't know what I pressed there. We're going to say from GPIO0 import, we'll start with an LED, which is the simplest type of device to work with. And we'll say L for LED is equal to an LED, and we need to say what it's connected to. So if you hover your mouse over here, it tells you what pins they are. And rather bizarrely, I don't know, there's two different pin numberings here. There's the physical pin numbers, so pin 1 and then pin 2 and all that kind of thing, or the board pin numbers. So you have to be careful if you're looking at the documentation online. So we need to find a pin number that isn't connected to power. So let's go for, here we go, the BCM number of that one is BCM2. So I'm going to put the BCM number in there, and that means that when we run it, we've got an LED connected to pin 2. Alright, so we've got an LED here. This thing is a resistor. A resistor resists the flow of electricity. It slows down the speed, the amount of electrons that can go down a wire, and it's important so the LED doesn't blow up and the amount of current from the Raspberry Pi doesn't damage the Raspberry Pi also. So the colours on a resistor affect the value. So if you want to read these, you can just search for resistor values, but you've got, I think that's an orange and another orange. So orange means 3 and then 3, and then brown here means 10 on the end. It's a 330 ohm resistor. So if you wanted to try this with the physical components, that's what you'd need. And then the beauty of GPIO0 means that once you've got an LED object, you can just say on, and then it flashes, and then L.off, and it goes off. Notice the speed that your Python program runs is really fast, so even though we switched it on and off, you don't ever see it on, unless, I guess, you import time and say time.sleep for 1 second, and then it will go off afterwards. And then you can have as many LEDs as you like, and hopefully they'll get connected to different ports. It gets a bit messy with the wiring, as you'll see, but you can design and test your program in simulation, and then try it out with the real thing if you want to and if you can. Sorry, struggling to get the right scene back. Okay, so let's go for some motors instead. So let's make a motor. This time we're not going to import LED, we're going to import a motor class, and we'll say motors, and we're going to make a list of them because there's 6 that control this Raspberry Pi thing. So we're going to have a motor connected to, so these numbers I'm going to put in now are the pins that I've connected them to on my Raspberry Pi. Doesn't really matter if you put different values in here. So you can see pin 14 and pin 15, and we've also connected power and ground, so 0 volts and 5 volts here. These chips allow us to control the speed of the motors. So in my case, there are some of these chips inside the circuit. There were some of those chips already inside this toy, and I just soldered them in with this kind of pin layout. Okay, so we need 6 of them. I'm going to put them all on separate lines. So 2, 3, 4, 5 and 6. Let's get the right pin numbers. Now you need 2 pins for each motor, 1 pin for making it go forwards and 1 pin for making it go backwards. And if you want it to go fast, then you keep the power on for a long time on that pin. If you want it to go slow, then you just put little spikes on that pin, and GPI0 does all of that for us. So what numbers do we need? 17 and 18. and 27 and 22. Some pins have different uses on a Raspberry Pi, so you've got to be careful about those. You can read up the documentation if you want to. 9 and 10, and then 25 and 8. So we've now got 6 motors. Notice you can power 2 motors off the same H-bridge controller, the motor controller, which is quite handy. Let's take out that last comma, we don't need that. So this is a list. We've got 6 different motor objects all inside a list, and we're calling that list motors. Why do we want to do that? Well, so that we can access one from that list and then say forward at speed 1, and then the first one in the list moves forwards. But I guess what we want to do is do something with all of the motors. So this is iteration now for M for motor. In our list of motors, now instead of saying which position within our list, so 0, 1, 2, 3, blah, 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 we can just say M. Help, indent, there we go. So for each motor in our list of motors, we can make them all spin forwards. Okay, now instead of all spinning forwards, I want them to stop. So we can call the stop procedure, and they all stop, and that's going to be quite useful. I want to use that lots of times, so I'll give this section of code a name. I'm going to define a procedure, def, called stop all, and then all of the lines of code to do with stopping all the motors just goes in there. That means that I can now say stop all motors and call that procedure, and they've all stopped. Great. Now we're going to put some commands in there so that you can choose which motor to control and then set the speed of them. So let's first of all ask the question, which motor do you want to control? So ask the question with input, which motor should I control? And then we need to say 0 to 5. You can adapt it so it says 1 to 6 if you prefer. And then you need to listen to the answer. So I'm going to say motor is equal to, and then remember input always gives some text, as in a string. We need to convert it to a number, so we can say 0, 1, 2, 3. We know which motor we're controlling. So motor is now going to store a number. We also need to ask how fast, and that's going to be a number from -1 to +1. But that can be a floating point or a real number or a decimal number, as in 0.5. It's not just integers, which is what int stands for. So we ask the question, how fast? And we'll say what the user should type in, -1 to 1. So far it stops them all, it asks you which motor, and then lets you type in a value, but it doesn't control that motor yet. So in order to do that, we're going to say, right, we access the list of motors, and then we use list indexing, the square brackets, and we put a number in here. That would mean the first motor, that would mean the second motor, or if we've chosen a number, we can use the number we've chosen, motor, which was the number we've typed in, and then make it go forwards at that speed, which will hopefully work. We'll say motor 0 should be this one at speed 1, and it does go round. But if we say motor 0 -1, it doesn't go backwards. We're going to have to put some logic in here, because this is a logic error at the moment. It does what we've told it to do, but it doesn't do what we want it to do. It doesn't crash, doesn't give us an error message, which means logic errors are the hardest ones to track down. So in order to do that, we're going to have to put in some extra logic. If the speed is less than 0, so if we've set a speed like -1, then we're just going to adjust the speed. We'll say speed equals 0 minus what we typed in. So we stop it from being a minus number. And then instead of saying forward, we say go backward at that speed. And then we can say else. So if it is greater than 0 or equal to 0, we can just move forwards at the speed as we did before. If I can spell forwards properly. Here we go. So control motor 0, go forwards. Good, that works. Motor 0 minus, and it goes backwards. Good, it works. What I'd like now is some iteration, so it keeps on looping round until we've had enough or we close the program. So we're just going to put all of the lines of code that we want to be repeated inside a loop, and I'm going to do while true. So while keeps repeating code whilst a Boolean expression is true. That sounds complicated. It just means whilst this thing here is equal to true. So we could put some logic in there, but true just means it's going to repeat forever, or until the program, or the user chooses to quit the program. So hopefully now we can choose one motor, and then choose the next motor, and then choose the next motor, which, oops, I just said put the speed to 0. Let's try again. 3, 1, there we go. So it does work, but if we try this on the actual device, where are we? With all of these motors going, it would just fall off the table and break. So I'm going to put in some extra logic to, when you press enter, it just stops all of the motors. So to wait until the user types in something, I'm just going to say input, press enter to stop all motors. And notice input asks a question, but we're not saving the answer. It doesn't really matter what they type in, they can just press enter. And then finally we use this procedure that we made before to stop all the motors. Stop all. Fab, let's try. So -1 and then press enter to stop, and it kind of works. So you've got some challenges to work through. If you submit some code for this one, the winner, I'll try and run your code on the actual device at the start of next week's episode. If you work through some of these. Number 1, try and make it crash if you don't put a number in. For example, if I put potato in here, it can't code because it tries to convert potato into an integer and it fails. So you can look up exception handling, which we covered last week, so that you can try and make it a bit more robust. Or you can try and make it so that you can type exit and it quits. Or you can make it so that you can press test, and you'll have kind of a nice little sequence of maybe the first motor going on for a bit and then the second motor, all of that kind of thing. So slightly longer video this week, and slightly off topic, but you voted for it. If you want to go back to stuff that's specifically relevant to the GCSE or to Key Stage 3, then do vote for options for next week. It's looking like it'll be file handling, saving to a file or reading from a file. If you want to do something else, just make a suggestion on live.withcode.uk and I'll do my very best to talk you through next week. Remember, you can find links to all of the remote learning activities on live.withcode.uk or in the links in the description underneath this video. Look after yourselves. Thanks ever so much for your hard work. All the very best. Bye-bye.